Bismillahirrahmanirrahim. The major sites of heme biosynthesis at organ system level are liver and bone marrow. Liver synthesizes heme proteins involved in xenobiotic metabolism, and here the rate of heme synthesis is highly variable. Heme synthesis occurs according to the changing demands of the heme proteins. Whereas in bone marrow, heme synthesis occurs in erythrocyte producing cells of bone marrow. Here the rate of heme synthesis is relatively constant and it matches the rate of globin synthesis. 85% of all heme synthesis occurs in erythroid tissue. Mature red blood cells lack mitochondria and are unable to synthesize heme. At cellular level, the initial and the last three steps of heme synthesis occur in mitochondria, whereas the intermediate steps occur in cytosol. All the carbon and nitrogen atoms of the porphyrin molecule are provided by glycine, which is a non-essential amino acid, and succinyl-CoA, which is a TCA cycle intermediate. These condense to form delta amino levulinic acid or ALA in a reaction catalyzed by ALA synthase. This reaction requires pyridoxal phosphate and is committed and rate limiting step in porphyrin biosynthesis. When porphyrin production exceeds the availability of the apoproteins that require it, heme accumulates and is converted to hemin by oxidation of ferrous to ferric. Hemin decreases the amount and therefore the activity of ALA synthase by repressing transcription of its gene and increasing degradation of its messenger RNA and decreasing import of this enzyme into mitochondria. The cytosolic condensation of 2-ALA to form PBG or porphobilinogen by zinc-containing ALA dehydratase or PBG synthase is extremely sensitive to inhibition by heavy metal ions, for example lead, which replaces the zinc. This inhibition is responsible for the elevation in ALA and the manifestation of anemia seen in lead poisoning. The condensation of 4 PBG molecules produces linear tetrapyrrole. Uroporphyrinogen 3 undergoes decarboxylation of its acetate groups by uroporphyrinogen 3 decarboxylase, generating coproporphyrinogen 3. The reactions occur in cytosol. Coproporphyrinogen 3 enters the mitochondria and two propionate side chains are decarboxylated by coproporphyrinogen 3 oxidase to vinyl groups, generating protoporphyrinogen 9, which is oxidized to protoporphyrin 9. The next step is the introduction of iron in this protoporphyrin 9 to produce heme. So here we can see that iron is incorporated in the center and protoporphyrin 9 is converted into heme. So that's the heme. To summarize, bone marrow synthesizes heme for hemoglobin, liver synthesizes heme for mixed function oxidases, glycine and succinyl-CoA condense to form ALA, 2-ALA condense to form porphobilinogen, 4 porphobilinogens condense to form hydroxymethylbilane, and hydroxymethylbilane then cyclizes to form uroporphyrinogen 3. Uroporphyrinogen 3 is decarboxylated to form coproporphyrinogen 3, which is decarboxylated and oxidized to form protoporphyrinogen 9, which is further oxidized into protoporphyrin 9. And when iron is added to protoporphyrin 9, it is converted to heme.